So going further, so question 1, what is the difference between a vector and a scalar? All right, so solution, a vector is a quantity that has both a magnitude and a direction. For example, velocity. Yeah, for example, velocity is going in this direction. So you have, let's say you're going 50 miles an hour. So you're going 50 miles an hour and there's a direction there. And then a scalar, difference between that is it only has a magnitude. A scalar is a quantity that only has a magnitude, for example, temperature. Yeah, so temperature, if you have 50 degrees Fahrenheit or Celsius, it's you're just going to say that quantity, it's, there's no direction in it. It just states that quantity, that's temperature of the room or whatnot. All right, so let's continue to question 2. So how do you add two vectors geometrically? And then also we're asked, how do you add them algebraically? So geometrically, so here's the solution. So we can add two vectors geometrically using the triangle or parallelogram law. And here what I've done is I just copied and pasted from my calculus book, because again, this is just a review on it. I'm not going to go into these in depth, so that's why you have to make sure to watch my earlier videos, all in the links here. So all these, this whole chapter, you can watch those and where I break them down slowly. But here I'm going to basically almost rapid fire through these, just to, again, it's a concept check and to review that we're understanding this all properly. So how do you add two vectors geometrically? We can add two vectors geometrically using the triangle or parallelogram law. So if you have a vector like this, so u plus v, so you would take v, put it at the end or at the tail, I mean at the head of this arrow there for u, and then draw u plus v there. So that's a triangle law. What you could also do is, let's say you could also go u like this, and then v like this, and then you can combine, and then you can move this v over to this side, like that, and then u on this other side. You basically draw a parallelogram where these are parallel. Yeah, so these are parallel, and then you can draw this u plus v or v plus u, and it's the same thing there. And we can add two vectors algebraically by adding their components. So if you know the coordinates of them, or the components of vectors a and b, so if you have the vectors a is coordinates a1 and a2, and b is b1, b2, then you can just add each ones individually. So a1 plus b1, a2 plus b2, so b2, yeah, this one like that. So that's how you can add them up like that. And we can visualize the geometric and algebraic vectors, vector additions at the same time. So here's a graph showing both of them. So here's A, and then you could put B on top of there. So you're adding these together. So you would put the B vector at the end. So the tail of the B connects to the head of the A. And then you could also put that in coordinate form. So the coordinates of this A is going to be a A1, and then A2, like that. A bit messy. But anyway, that's this A1x, and then the Y is A2, and here you can see the visually. So there's A2, B2, that's the Y component of it, like that. And then the X component A1, B1, like that. Just epic stuff there. All right, let's continue further. So question 3, if A is a vector and C is a scalar, how is CA related to A geometrically? And how do you find CA algebraically? So geometrically, CA shortens or extends A. Yeah, so if you have a vector A like this, with components A1, A2, so the X and Y, C, multiplying by a scalar, just multiplies all the components as well. This goes up, and then basically it's just exactly the same thing here, but scaled up. This angle is exact same. But this is going to be CA1, CA2. So everything's just scaled up and basically stretches it. So, and if you have a smaller number C, less than 1, it will shrink it. If you have a negative, it goes opposite. All right, and we can find CA by multiplying the components of the vectors A by scalar C. So if A equals A1, A2, and B equals B1, B2, then you have, and also this was actually added earlier. Yeah, this was added earlier for the addition right here, but you could also do the same thing with subtraction. So A minus B vectors, you can just subtract the components. And then C is scalar times by A vector, you just multiply the components. And same thing in 3 dimensions. So in similarly for 3-dimensional vectors, so A1, A2, A3 plus B1, B2, B3, again, you add the components, and you can subtract the components, and you can multiply with a scalar into each component. All right, so again, that's pretty epic stuff there. So pretty simple.